When calculating electrical loads, it's important to understand the differences between single-phase and three-phase systems. For 120 volts lighting circuits, you correctly calculate the load by summing the wattage of all the fixtures on that circuit. For example, if you have a circuit with 8 50 watts light bulbs, the total load is simply 8 multiplied by 50, which equals 400 watts. The 1.732 multiplying factor, which is the square root of 3, is specifically used in three-phase calculations to account for the phase shift between the three phases. This phase shift results in a higher apparent power compared to the actual power consumed. This factor is crucial for accurately determining the current draw in a three-phase system. The 1.732 factor arises from the geometry of the three-phase system. Imagine three sine waves, each representing one phase, offset by 120 degrees. The voltage between any two of these phases is not simply the difference of their instantaneous values. Instead, it's the vector difference, which introduces the square root of 3. In a three-phase system, power is calculated as volts multiplied by amps multiplied by the square root of 3 multiplied by the power factor. Since lighting runs on a single phase at 120 volts, you do not need to apply the 1.732 factor to your calculations. You only need to consider the wattage of each fixture to find the total load. For the three-phase 208 volts air conditioning unit, the 1.732 factor becomes necessary. To determine the current draw of the air conditioning unit, you'll need to know its power rating in watts or kilowatts. If the power rating is given in kilowatts, convert it to watts by multiplying by 1000. Then, use the following formula to calculate the current. Amps equals power in watts divided by volts multiplied by 1.732 multiplied by the power factor. The power factor represents the efficiency of the electrical device. It's the ratio of real power to apparent power, typically ranging from 0.8 to 1. A higher power factor means the device is more efficient in using electrical power. The power factor is usually found on the device's nameplate. In the formula, amps equals power in watts divided by volts multiplied by 1.732 multiplied by the power factor. Volts refers to the line-to-line voltage, which is 208 volts in this case. This calculation gives you the current draw per phase of the air conditioning unit. Understanding the application of the 1.732 factor is crucial for accurate load calculations in three-phase systems. Failing to include it can lead to undersized wiring and potential overloads. By correctly calculating loads, you ensure the safety and reliability of your electrical system. To summarize, firstly, calculate the lighting load by summing the wattage of all 120 volts fixtures. Secondly, use the 1.732 factor only when calculating the load for three-phase 208 volts equipment like the air conditioning unit. Thirdly, remember to include the power factor in the three-phase calculation for an accurate current draw estimate. Finally, consult local electrical codes and regulations to ensure compliance with all requirements.